Hi guys, Miss Angel here. Hello. Today we're going to be focusing on Unit 2, Lesson 3, Rational and Irrational Numbers. So first off, if you haven't watched my video from the last lesson, Unit 2, Lesson 2, I would encourage you to go do that because I actually go into a lot of detail in there that applies to today's lesson, okay? So that could be a good starting point, but hopefully this will help as well. There's a lot of really good information within your lesson, so go through the lesson, go through it in detail, take your time, limit your distractions around you, all of those good things that make it so we can focus as best we can, all right? For today's video, I'm going to do 3 problems. A couple of them are like modeled after actually only one of them. This one is modeled after one of your problems on your practice on page 13 of your lesson. Sorry, I'm looking at my other screen. The other 2 are directly taken from your practice on page 13, but also one of them is from your quick check on page 14. All right, so let's get started. Pause this video if you don't already have a piece of paper, your notebook, pen or pencil, all those good things. Okay? So, like I said, Unit 2, Lesson 3, Rational and Irrational Numbers. Oops, too bad. So we only look at one at a time. Number 1, which of the following is a rational number? All right, so remember, a rational number is a number that can be written as a fraction using integers, where the denominator, that's an important word, right? That's the bottom number in a fraction, can't be 0. So that brings us right here to this first number, 3 over 0. Because the denominator is 0, all right, this cannot be a rational number. That's part of the actual definition of a rational number, okay? So I'm going to cross that one out. That one cannot be a rational number. This next one, 6 pi. Well, pi is a number, but it's just a symbol represented here, right? But it represents the number 3.1415, and it goes on forever and ever and ever, making it an irrational number because there's no pattern to it, and it goes on forever. So we just represent it with this symbol here. When you have 2 numbers right next to each other like that, it means they're being multiplied by each other. So really this is like 6 times pi, okay? But because pi is irrational, the whole thing is irrational, all right? Okay, how about this guy here? Well, it's a decimal, and one way you can think of rational numbers is that they end, right? If you remember from 7th grade, it talks about like terminating decimals, meaning they end, right? They have a stopping point. In this case, that would be the 5, okay? Because it stops, it is rational, all right? So this is a great option for our final answer, okay? It could be written as a fraction actually as well. If we pay attention to the place values, well, we have tenths, hundredths, thousandths, 10,000ths. So I could take that and I could write it as a fraction by just listening to how I say the number properly, right? So this would be 7,215 10,000ths. That th at the end signifies that it's a fraction, so 10,000ths. So right there, because I was able to write it as a fraction using integers, it's therefore a rational number, okay? Now this one here, there are some square roots that can be rational numbers once you solve them, but being that this is not a perfect square, okay, it's therefore irrational, all right? So that can't be our answer either. We'll talk more about perfect squares in problem number 3, okay? All right, moving on to number 2. Which of the following is irrational? So now we're focused on the opposite concept from what we were looking at in number 1. Sorry, I'm trying to get centered and I have to think opposite for it. It's kind of weird. All right, which of the following is irrational? So this one right here, this is a mixed number, but because it was able to be written as a fraction where the denominator in the fraction is not 0, it is rational. So that cannot be irrational. All right? This next one, this is a repeating decimal, right? And it could have even, like, we could have put 3 little dots there to show that, like, it goes on forever. But because it has a pattern, okay, it is actually considered rational. So that can't be our answer. This one here, the square root of 2 divided by 3, or the square root of 2 over 3. Because there's a square root, and it is not a perfect square, therefore it is irrational, okay? Because the square root of 2, it's going to go on forever and ever and ever. All right? So this is a good candidate for our answer, but we always want to check every single one. All right? So with this one, 87 and 9,821 10,000ths, because it ends, it's therefore it is rational, so that cannot be our answer. So this one right here, that one is going to be our final answer. Okay? All right, one more problem. This one's got a little bit of depth to it, so we do need to make sure that we take some time for this one. And it's a lot of information, so feel free to re-watch this or anything like that that you might need to do. So it says estimate the value of 6 times the square root of 2. So the reason why we're estimating is because the square root of 2 is an irrational number. It's impossible for us to write the entire thing. Okay? So we're going to estimate. But notice a lot of these numbers are like really close together. Okay? This is a problem actually taken from your quick check. At least on the one I'm looking at, it is number 3. So you might want to write that down. Okay? So which of the following choices is the best estimate? Okay, sometimes there's good estimates, like a lot of these might be good estimates, but there's one out of them that is the best. Okay, so that being said, let's talk about perfect squares first of all. So a number, when it's squared, means it's being multiplied by itself. Okay, so let's take like 1 squared. That would be like 1 times 1. Well, 1 times 1 is just 1. To work backwards from that, okay, to find the square root of 1, we're trying to figure out, well, what can I multiply by itself to get to 1? In this case, it's just the number 1. That would look like this. Okay, the square root of 1 equals 1. Now, so that's a perfect square because I was able to do that with whole numbers, right? Even natural numbers. We could go into more detail for that. So let's think about if I were to take the next natural number, so 2, if I do 2 squared, 2 times 2 equals 4. So 4 is a perfect square, right? And we can even draw a square and say this side is 2, this side is 2. If I multiply those together, I get 4. Okay? Well, so just like we did up here, we can then think the square root of 4 is 2 because 2 times 2 equals 4. All right, let's try another one. If I take 3 squared, well, that's equal to 3 times 3, which equals 9. That means 9 is a perfect square. Okay, we could do that same thing for those of you that like to have a visual, I could say that this side of a square is 3. That also means that side of a square is 3. Break it up. 3 by 3, that equals 9, right? It's a perfect square. So once again, we can think, all right, well then if I take the square root of 9, right? The square root of 9 is 3 because 3 times 3 equals 9. All right? So hopefully that kind of helps us when we're thinking about this problem here. Okay? Oops, I'm drawing on my desk. So the 2, and there is information about estimating square roots in your lesson, so make sure you pay attention to that. With this one, well, the 2 right around it, right, the 2 perfect squares right around it are going to be the square root of 1 and the square root of 4, right, because that's 1. These are the 2 perfect squares right around it. The square root of 2 would be right in between. Okay, that equals 1, and that equals 2. So we know that the square root of 2 is going to be somewhere in between the numbers 1 and 2. Well, the most obvious place to start first off is going to be 1.5. Right, if I multiply 1.5, let's see what happens if we do 1.5 times 1.5, right? That I'm going right in between those two numbers. Well, if we're trying to get back to the square, we got to multiply them. So 5 times 5 is 25. I'm going to drop my 5, carry my 2. My decimal is going to, oops, excuse me, I shouldn't have done that. I was mixing, adding and subtracting. 5 times 1 is 5, plus 2 is 7. I'm going to annex my 0 so that I can start multiplying by the 1. 1 times 5 is 5. 1 times 1 is 1. Add those together. Oops, let me move it up so you can actually see it. Add them together. We get 5. 7 plus 5 is 12. I'm going to drop my 2, carry my 1, and 1 plus 1 is 2. I had 2 numbers behind my decimal in my problem, so I should have 2 numbers behind my decimal in my answer. Okay, so far, 1.5 times 1.5 is 2 and 2500ths, or 2.25, right, is the way we look at it. At least, so that's pretty close. We almost got there, or we almost got to that 2, but I think we could get closer. Okay, we want our answer to be slightly lower than that. So I'm going to go slightly lower than 1.5, and I'm going to say 1.4. So I'm going to do 1.4 times 1.4, and let's see where that gets us. Okay, so again, we're going to multiply them together. So 4 times 4 is 16. Drop your 6, carry your 1. 4 times 1 is 4, plus 1 is 5. I'm going to annex a 0 so I can start multiplying with my 1. 1 times 4 is 4. 1 times 1 is 1. And then I'm going to add those together. 6 plus 0 is 6. 5 plus 4 is 9. And then we just have that 1. We'll bring it down. Once again, we had 2 numbers behind the decimal in our problem, so we'll have 2 numbers behind the decimal in our answer. Alright, you can always check your work with a calculator. I'm all for that. I use calculators all the time. But one thing to consider is that, like even on standardized testing and things like that, you don't always have a calculator. Sometimes they make you actually do the work, okay? So that's what this is. This is actually doing the work, okay? So look how close we are to 2. We are so much closer to 2 right here than we were right here. 1 and 96 right? If you think of it in terms of money, that's like $1.96. That's really, really close to $2, okay? So the reason why we did all of that, all right, is because we can say that that is our estimate for the square of 2. Okay? So then, what we can do is we can take that amount and we can take that amount and we can put it right here. Well, the square root of 1.96 is 1.4. Okay, so the square root of 2 is about 1.4. Okay, I know that's a lot of information. All right, but we can say that because 1.4 times 1.4 gave us 1.96, which is really, really close to 2. Okay, so what I'm going to do, I need this for that original problem. All of that work was to get us back to say the square root of 2 is about 1.4 so that I can put that in my original problem and say, right, because remember we're estimating, so our estimation is going to be 6 times 1.4. You've hung on with me for this long. Let's see, we can do one, sorry, my dog barking. I'm going to do it up here because I'm running out of room on my paper. 1.4 times 6, okay? Well, 6 times 4 is 24. 6 times 1 is 6, plus 2 is 8. I only have one number behind my decimal, giving me 8.4. All right, one number behind my decimal in the problem, one number behind my decimal in the answer, 8.4. Let's see, was that one of the answers? Yes, it is. There it is. For me, that was answer A. Doesn't mean it's answer A for you, so make sure that you keep track of that on your paper. Okay? So, we're going to practice this a whole bunch in live lessons, so I encourage you to come to that. Watch the videos throughout your lesson, and we'll go from there. Okay? Have a good day.